I want to talk about is a number of different things today, and obviously I'm going to start with a little bit about One Aviation, where we're at, what we build, what the plan is, and then I want to talk a little bit about general aviation more broadly, and touch on, you want to hear a joke? Touch on briefly, that's the joke with me. Try and be brief about some other issues that are going on in the industry that I think all of us should be paying attention to, and thinking about what our own opinions are, how we would solidify those opinions, and what we're going to do about them. So let's start with One Aviation, then we'll come back to a little bit of history. So One Aviation, a new name that many of you may not know. The name comes from a business philosophy. It wasn't what we were originally going to use for a name. It actually belongs to Ken Ross's mother-in-law's idea. But Mason and Ken and I and a bunch of other people were beating around, what are we going to name this new entity when we came up with the idea of, well, One Aviation. And the reason we chose the name is because it does describe what we're trying to do. We're trying to have one company that takes into, under its wings, a variety of different aircraft designs, aircraft manufacturing methods, how we will then work with the customer from the sales through the purchase to the operation, and eventually the disposition of the airplane. How do we change the way we interact? The way I like to describe it is that One Aviation is not about how do we build a better airplane, although yes, we think we'll be doing that. It's how do we build a better aircraft company. Many, probably most in this room, are in aviation because we love it. I don't remember a time when I wasn't in love with aviation. Having said that, we can't expect to have a healthy aviation industry if we only rely on people who love it. It has to actually make economical, rational sense. So we have to have good products, good business process. We have to do the right thing for customers. I am sufficiently confident that if we do that, it will come full circle and those people will love airplanes as well. I actually get a kick out of now having been doing this for I don't know, lots of years. I think this fall is 40 years since I started learning how to fly. How many times I'll run into people who have been in aviation for 5 years and they'll have bought a Cirrus 5 years ago, or they got their first ride last year in an LSA or something like this, and they will just be over the top in love with airplanes and try and convince me that I have to do that too. You're right, yes, absolutely, let's go flying. I think that's a great idea. But that passion, while I expect some people to start there, I expect everybody to end there, isn't a path. And so what we have to have is a path that gets people there. From a One Aviation point of view, the introduction, we use the word merger. I do normally describe it as, think of it as a merger, technically the structure, and so that it doesn't get misunderstood. One Aviation is a holding company. One Aviation owns Kestrel, owns Eclipse. There will be other things that we'll be adding to the mix. But it isn't a merger of Kestrel and Eclipse. So from a business point of view, what's the logic here? What's the better business? Well, the better business from a business point of view is, excuse me, how do you divide the costs over more customers, right? How do you make the economics of it better? How do you leverage the resources you've got? Eclipse obviously knows a lot of things about jet airplanes and about aluminum airplanes and about things like that, but they don't know a lot about composites. Well, it turns out Kestrel knows a lot about composites, but not about jet aircraft and some other things. So there's a lot of overlap and benefits that we can use to our benefit. So that's part of this idea of building the better company. But in the long run, what we really want to do is have the financial strength to be able to do whatever is the right thing to grow the company, as opposed to whatever we can manage to do next and afford, right? Isn't that what we all go through? It's not, while there's a lot of different paths you can choose, and multiple right paths and a whole bunch of wrong paths, you end up being limited by the financing, the capability, the resources of the company. So that's what we're trying to do, is make sure we've got more ability to be flexible in how we do things in the future. So right now, the airplane that's in production is the Eclipse. It was funny, Steve, as you were talking about the Collier Trophy and the history of Eclipse and Cirrus, but there were a lot of parallel developments going on there. And obviously, I have known Vern Rayburn for a very long time. I knew about the Eclipse when it was originally known as Pronto, if everybody knows back that far. It wasn't an Eclipse in the beginning. And at Cirrus, we had our own single-engine jet concepting from the very beginning. And we shared a lot of the same investors and the same views of the future. Jim Fallows wrote a book that you may know. Jim Fallows is a writer for the Atlantic Monthly and wrote a book called Free Flight that talks about a number of things about the future of general aviation. But two of the examples are Cirrus and Eclipse. And so Jim has teased me, as have others, that in this book about the differences, I would end up on the other side of the fence. But Eclipse is a twin-engine jet. The term VLJ has been tossed around a lot from an Eclipse point of view, very light jet. But I think of it first and foremost as a personal jet. It obviously, because of its tremendous economics, it's a really low-cost operate airplane, fits into a variety of other niches in terms of its use. But I think of it as a personal jet. The personal jet aspect of the Eclipse is unbelievable personal performance. It is a really economical way to get around at very high speeds. My typical trip right now is Duluth, Minnesota to Albuquerque, New Mexico, and it will do it significantly faster on less fuel than the Piper Meridian that I've been flying for the last 5 years. So pretty cool that you can have a twin-engine jet that burns less fuel than a single-engine turboprop in that case. So cruises about 360, 365 knots on a cold day. You actually have to pull the power back because it'll go too fast. One of the things I've learned is how much difference temperature makes, because on a hot day you wish you had more thrust. But very, very fast, very, very economical. Ken Ross, who's been the president of Eclipse, and I had a running argument as we were putting these companies together about altitude. And he was completely wrong. See, because he thought that 28,000 feet was high enough. And I kept saying that no, you're right. I said that 28,000 feet was high enough. And so it turns out that the Eclipse, which will cruise at 41,000 feet, really does have some significant advantages in terms of getting over weather, getting out of turbulence, getting into better winds or out of worse winds. So Ken won that argument. He was right. I was impressed. You don't believe it until you actually experience it. So it's a very efficient, very fast, high altitude personal jet. The airplane is back in production, something that some people haven't been aware of. It's now known as the Eclipse 550 instead of the Eclipse 500. There have been constant updates in the equipment on the airplane. One of the things that Mason and Ken have done over the last, was it 5 years? 6 years now, I guess. Anyway, 5 or 6 years, is they took Vern Rayburn's vision and said, okay, it isn't going to be an $800,000 jet. And when the original company went out of business, it wasn't finished. There were too many unfulfilled promises. So they spent the last 5 years or so fulfilling those promises, making sure that the avionics work, making sure that it is FICI certified at altitude and all of these things. But we're now at the position where we can then take that further, and we'll be now increasing production, making sure that people understand the right niche of the airplane, and think Porsche 911. Also, by the way, in case you didn't know this, you can get a Mazda Miata for less than a Porsche. And so if you want to go pay less than what it costs to get an Eclipse, you can get your Mazda Miata. But it's a pretty cool airplane. The second airplane in here is the Kestrel. It's not in production yet. It's something I feel very passionate about. It's a very large turboprop, single-engine turboprop. Not as big as a PC-12, but cabin volume-wise, much larger than a Meridian or a TBM. It'll seat 6 to 8 people. The way I normally describe it is, if at either end of your mission you have a short grass runway, then the Eclipse isn't going to work for you. You're going to need something more like a Kestrel. So composites versus aluminum. This is sort of an interesting mix here, and something that I also get asked a lot about. My Kestrel background in composites obviously goes back further into the Cirrus, which goes back into college days and a long time. I started designing the original Cirrus VK30 in 1979 when I was a physics major. And it was a composite airplane because what we were looking for was performance. Composites it better allows you to get to natural laminar flow. So it was all about the aerodynamics. It turns out that back in the 1970s, there were other things going on. We were talking about the Starship a while ago and some other attempts at composites. But we tried to look at composites differently. And what you would normally hear is that you can build a lighter airplane with composites. And while that may be theoretically true, it's only theoretically true in corner cases. The Eclipse is chemically milled, very thin skins, friction stir welding, a lot of very high technology in terms of the aluminum manufacturing that gets it to very light weights. In order to get those similar kinds of light weights out of composites, you have to go to some equally unique and therefore expensive manufacturing techniques. At Cirrus, what we shot for was the in-between case. We didn't try and have the best material properties, the closest tolerances, any of these kinds of things. We tried to have great aerodynamics and low cost, crashworthiness, good looks, things that composites get to easier. So that was a great experience. Learned a lot about composites, manufacturing, dealing with the FAA, and so on. And so I've got a fair amount of experience and some reputation now, and so people will say, again, like the Jim Fallows book, well, you're building an aluminum airplane, shouldn't it be a composite airplane? And the answer is no. I mean, every different product, there's a different set of compromises. As we do that on airplanes, though, we want to continue to do that in other areas. We were talking about insurance. Obviously, aircraft finance is an issue. How do people flight train? How do people use their airplane? So let's talk about flight train for a minute. I'm a jet pilot. That means I went through what the FAA describes as a type rating. It was very frustrating for me. Also very positive, obviously in terms of what you learn, but the way I did it was in an Eclipse, flying places, doing the missions that I would have to do anyway, and learning to operate the airplane. So I feel very comfortable with the airplane. I love the way it flies. We were talking about landing gear. I mean, when it touches down, you have a hard time telling where the touchdown was. You feel the initial touchdown and the wheels spin up, but then it just sort of settles in softly into these trailing link gear. It's really cool. But I have multiple birth defects, but one of them is don't laugh at me. It's not my fault. It's my parents' fault. I ask why to everything. So you can imagine this driving the instructors absolutely nuts. So they'll say, here's the way you have to do it for the type rating. Why? Well, because it works like this. Well, why? Why don't we change this? We could do it this way, and why don't we do it this way? And how come that matters? And how come we have to do it this way? And finally pull out the FAA practical test standards, because it says so in the book. Oh, okay. Why does it say it that way in the book? So we have to build the better industry. That's what we have to do. We have to look at the market and not say, woe is us, not enough people care about airplanes. What we have to say is, they don't understand. It's our job to go out and educate them, open their eyes, teach them, show them what this better world can look like, show them aviation.